There we go. So good afternoon, everyone. My name's Jesse, and I am with Exploring by the Seat of Your Pants. For those who don't know, we're all about bringing conservation, adventure, and science into classrooms around the world. Today, I'm really excited because it's in the middle of our Space Week. So we've been having hangouts with the astronauts, engineers, science writers, all sorts of great people from the space field all around the world. So it's been really thrilling for us. It's our first time we've ever done it. Right now, we're joined by 3 classes from across North America, so I'm going to give them a chance to do a bit of a shout-out, and then we'll go on to our speaker. So first, we've got Mrs. Adams, grade 4-5 from Enrico, Virginia. Hi, guys. Okay, setting the bar high, we've got Mrs. Gibson's grade 6s from Grafton, Ontario. Feeling high pitched. Okay, and then we've got Mrs. Aspin's grade 4s from Anaheim, California. One kid sort of like took the day there. All right. You guys are all here, of course, today for our amazing speaker. We're joined live by Emilylakdawalla. She is a senior editor and writer for the Planetary Society. She's one of the few people who gets to take her passion and do it full-time for a living, which is marvelous. She's a planetary evangelist, which means she gets to share a love of the cosmos with everyone on all sorts of platforms. For you kids, you'll be happy to note she has over 140,000 followers on Twitter, making her one of the most popular space writers in the world. So she got a chance to share some great space books with us before we started the hangout. Without further ado, thank you so much for joining us, Emily.
Hi, I'm so happy to be here. I'm so happy to talk to kids. You know, I actually used to be a middle school science teacher. I learned to talk to people. I was a little kind of shy and afraid of talking in public before I had to do it every single day in front of a whole lot of 5th and 6th graders, talk about general science and earth science. And of course, I didn't talk all the time because what's science if you're not like experimenting with your hands and doing things? So I feel kind of bad about having to stand up here and talk to you the whole time. So I'm really looking forward to answering your questions. But first, I will tell you a little bit about myself, and I will show you some really cool pictures from space. So let's go on and look at some really cool pictures from space. I'm going to share my screen. Okay. So this is me when I was in 4th grade. I always loved science. I didn't necessarily always love space. I always was interested in space. I liked dinosaurs too and all kinds of things. Here is me. I got the grand prize in 4th grade in my science fair project on the growth of plants, and I'm still proud of that. This is me a few years later when I was taking AP chemistry in high school. And as you can see, I continued to do science fair. After that, I went to college to study science. I wasn't sure what kind of science I wanted to do, but the college that I went to had a really good geology department. So I took geology, and I fell in love with geology in part because we got to go outdoors all the time. And it was in Massachusetts, and it was in the fall, and the trees were beautiful, and it was just so much more fun than being in the classroom all the time. So this is my favorite teacher of all time right here. Her name is Professor Tekla Harms. She was my geology advisor in college. And when you go to college and you start doing research, you do research under an advisor, and you can find a mentor who's really awesome. My mentor was Tekla. She was fantastic. Okay, so I did field geology. This is me in Death Valley back when I had long hair. And guess what? When you're in college, you still make posters about your research. So all that science fair stuff that you do as a kid, you still get to do it when you're in college and even in grad school and even as a professional scientist. So, okay, so now I'm going to tell you a little bit about how I got interested in space. So if you think about this picture back here when I was in high school, this was all in the 1980s. This was, I think this last picture here was taken in 1989. And that was around the time that the Voyager spacecraft were exploring the very outermost solar system. Here's an artwork from the 1970s of Voyager exploring Uranus and flying by it, and exploring Neptune and going past. And it sent back these fuzzy looking pictures of all these new worlds that I hadn't ever heard of. It might be hard for you to read the letters on this slide, but these are moons of Uranus, and they have wonderful names: Miranda, Ariel, Umbriel, Titania, and Oberon. And even though the pictures were really fuzzy, I just loved those names, and I loved all these new places that the spacecraft visited. So here's a picture of Umbriel. There again is, oh gosh, which one is this one? Now I'm on the spot. I think it's Titania, and that one's Ariel. That one's Ariel. Wait, what's the other one? I don't know. Sometimes they're a little hard to tell apart. Okay, so I really loved those pictures, but other than that, the 1980s were a pretty lousy time in space exploration. There was not a whole lot going on. The Russians were doing some really interesting things. These kind of hard to understand pictures are from spacecraft that Russia landed on the surface of Venus. Did you guys know that we had landed on the surface of Venus? These are pictures from Venus that the Russians took. I certainly didn't know that at the time. But apart from that, that was it. This is, excuse me, the screen is black because there wasn't a lot of new stuff coming down from space at that time. But then in 1997, which just happened to be the same time that I was teaching 5th grade science, something really big changed. We had a lander on Mars named Pathfinder, and it had an itty-bitty little rover named Sojourner. And there was this brand new thing called the internet. And you could see pictures from space on the internet. And I could go to my computer and dial up with my modem, and it would make all kinds of funny noises. And after waiting for about 15 minutes, it would download these tiny little pictures that had come from Mars. And at that time, the internet was still really young. The Jet Propulsion Laboratory couldn't handle all the attention, so they had to create mirror websites hosted by schools all over the country to help them share all of these new Mars pictures with the people who loved them. And then the same year, this spacecraft called Galileo went into orbit around Jupiter. It actually had been orbiting Jupiter for a couple of years, but it started sending back to Earth these amazing photos of Jupiter's moons, the same moons I'd fallen in love with from the Voyager missions, only they were much prettier in these beautiful colors. This is Ganymede and Callisto and Io and Europa. At the same time, the Hubble Space Telescope was also starting to return new great pictures from space. This is Io. It's a volcano on the side that's exploding right now, and we could see it from Earth. Here's a Hubble photo from Mars from 1997, and a Hubble photo of the asteroid Vesta. All of these were taken 20 years ago this year, back when I was a middle school teacher. Okay, so I went to, when I was a middle school teacher, I was a geologist. I wasn't sure what I wanted to do when I grew up. I knew I didn't want to be a teacher, because let me tell you, I want all of you kids to turn and give a little round of applause to the teachers in the classroom, because let me tell you, that is hard work. It's incredibly hard work. It's so hard. I said, I can't do this for a living. I'm going to go back to school and study, because that's so much easier. And so I went back to school and I got to study the planet Venus as a geologist. This is a picture of Venus that was taken by the Magellan spacecraft. And you can see a little river kind of thing, except it's not a river with water because Venus is too hot for that. This would have been a lava river at one point in the past. And while I was studying Venus, look at these amazing pictures. I got to look at these gorgeous pictures. I didn't know what they were. I mean, I see some fractures, and I think this is a volcano with lava flows and stuff, but what's this? This is the surface of Venus. Do you have any idea what you're looking at? I certainly don't, but it's really pretty, and I really enjoyed looking at all these amazing pictures. Look at this space jellyfish right over here. It's not a space jellyfish, it's a bunch of lava flows. But it's really cool looking, and I thought, these pictures are amazing. How come I've never seen these amazing space pictures before? I need to tell the whole world about these amazing space pictures. So I was really lucky in that after I finished graduate school and I spent a really short period of time working as an environmental consultant, I got to go work for a very special organization called the Planetary Society. And that's where I still work. We're a nonprofit organization. We advocate for space research and exploration. We do education. We tell the government that we want more space robots. And I write about space robots doing work across the solar system. And so I arrived there at a really good time. Here's a picture of the comet Borrelly, which we flew past in 2001. Here's Saturn, just as Cassini was approaching in 2001. Mars Odyssey went into orbit around Mars in 2001. And at around the same time, these two guys were scientists who were working on a mission called the Mars Exploration Rover mission, which was a space robot that they were going to send to Mars, just like Sojourner. And they were talking to us at the Planetary Society because they wanted to take all the pictures this robot ever took on Mars and put them on the internet for everybody to see in real time. And so that's what they did. They started putting all the images from their robots on the internet as soon as they arrived on Earth. And it started this whole internet community on a forum where we got to discuss, look what the robot is doing today on Mars. Wow, take a look. There's a huge dust devil in the background. This is so cool. And then the Cassini mission to Saturn did the same thing. And I started writing about it. Look, there's my byline. Cassini Images Iapetus by Emilylakdawalla. That's me. And I started publishing articles about all the cool pictures that the space robots were returning. Then a really special thing happened. We landed on Titan. In fact, it was both the NASA and the European Space Agency working together to send a tiny little space robot named Huygens to go land on the surface of a moon of an outer planet named Titan. And it sent back pictures that looked like this. And at first we thought, did they accidentally fly back to Earth and take pictures of rivers? Like, this looks like Long Beach to me, or maybe Long Island. I have no idea, but it looks like Earth. And these are the pictures that the space mission showed us about what the surface of Titan looks like. And then all those pictures got out onto the internet, and people, members of the public, not scientists, but just people on the internet who love space pictures, produced that. And it was a much prettier view. Then they said, oh, we know how to color this in. Let's color it in. And they made that. And now we have a view of the landscape of Titan as though you're floating down to the surface in a balloon. And it was so cool. So what I wanted to know after that was, who are these amazing people on the internet who are doing such wonderful work with these people, with these images, and how can I help them out? And so I figured out that here is the question that all these people wanted to answer. What would it look like if I were there? And this is a different question than scientists ask. When scientists look at their space data, they want to make things look as sharp and crisp and as many different colors as possible, and emphasize subtle differences so that they can get all the details that they can possibly get out of their data. But this is not what this planet looks like. This is actually the same planet. These are two pictures of Venus that were published by NASA, and neither one of them looks anything like Venus actually looks like. Do you want to know what Venus would look like if you were there? This is what Venus would look like if you were there. Okay, you see that? That's what Venus actually looks like, except not quite. Even this is a little bit overemphasized from what Venus would actually look like. That picture on the left is a photo from the Messenger mission. That is a color photo of Venus. If you were there, that's what Venus would look like. It looks like a cue ball. It's really, really bland. And if you were in a spaceship flying to Venus, that's what Venus would look like. You guys might also recognize these two pictures. These are our favorite outermost planets, Neptune on the left and Uranus on the right. And these are the most common pictures you're going to see on the internet of those two planets. But if you were actually there, if you could really put those two planets side by side, that's what they'd look like. Okay? They look a lot less blue. They're still blue, but they look a lot less garish. Here is a really popular picture of Saturn that shows what Saturn looks like in infrared wavelengths. And here is what Saturn would look like if you were there. Now, all of these things have The reason that I go on and on and on about this is because you could go now down to Joann Fabrics or your local fabric store, and you could buy this fabric right now. And what do you see? You see that weird colored Saturn. You see that weird colored Uranus and Neptune. You see Venus looking bright, bright, bright orange. And that's not what any of them actually look like. And so I always laugh when I see this fabric. And then my mom made a baby blanket for my baby out of this fabric, and it's really cute, but I still laugh every single time I see that little picture of Saturn. So if you went out to the solar system and you flew around it in a spaceship, here's what the true colors of all of those places would look like. And this is one of the things that I want to tell and explain to people, is how beautiful, how subtle, how pretty all of these various planets are. And that's what I do for a living. I'm going to skip ahead a little bit because I feel like I've been talking too long and I want to answer questions instead. So I'm just going to do one last little thing. I do have other pictures to show you. I'm just going to spin through a whole bunch of them. And I just wanted to mention that I'm writing a book. I'm turning in the manuscript. I've been working on this book for 4 years, and I am turning it in on Friday, and I'm very excited about that. It's not necessarily a book for kids, but there's a lot to learn inside it. And maybe my next book will be a kid's book. So thanks very much. And now I'm really looking forward to your questions.
Outstanding, Emily. That was marvelous. Your professional detachment aside, that was really cool. All right. So before we get into questions from the classes, I also want to note we have 19 groups watching online right now. So if you guys want to ask questions too, you can write them in the YouTube chat bar on the right, and then I can pass them along. So feel free to do that. Also for classes who are watching live, if you're taking pictures, hashtag explore space, and you can win some cool prizes at the end of the week. All right, let's go to do some questions. So Miss Adams' class, if you guys have a question, come on up.
Yes, how did they get the robots or the satellites to space?
Okay, so it's actually pretty old technology using rockets. Rockets, the idea is first invented by the Chinese a very long time ago. So all it is a whole lot of explosives in a tube, and we build a very strong kind of tube that doesn't blow up when you blow up explosives inside it. And it shoots a lot of rocket fuel at very high speed out the back end using by burning that rocket fuel. And that is how we send those things into space. What's wonderful nowadays is that you can watch rocket launches live on TV. You can watch it on NASA TV or online, or not just NASA, but SpaceX. Other space agencies air their rocket launches online. And a lot of rockets have cameras on them now. So you can see when the rocket flies into space, and you can see the stages, extra stages come off, and you can see the fairing split over the spacecraft, and you can see the spacecraft be deployed into space, like poof. It's pretty cool. So rockets are the enabling technology. They're very, very, very expensive. So what I'm hoping is that some of you guys in those classrooms will develop some new technologies that are less expensive, that will enable more of us to go to space.
Excellent. All right, we've got a kid like super eager in Mrs. Astron's class. So if you have a question, come on up, go right ahead.
Wendigo. Tell all those facts, but how long will it take to come back to Earth if you travel all the planets?
It would take a really long time to get to all of the planets, unless you had some kind of futuristic spaceship technology, which I do recommend developing. But let's say you're stuck with current technology. If you're an astronaut, you could probably get to Mars in a few months, and then you'd want to stay at Mars for a little while, and then it would take you another few months to come back. And that's just Mars, which is one of the easiest planets to get to, other than Venus. And so one of the big problems for astronauts is the fact that we don't know how to keep people healthy in space for that long. And so one of the places where we need people, excuse me, to do science work is in understanding how the human body works in space, and making sure that we can keep the astronauts healthy for these long flights.
Excellent. All right, let's go to Mrs. Gibson's class. If you guys have a question, come on up. Yeah, go ahead. Oh, I guess your mic isn't on or something, guys. I have it on my computer. I don't know. Worst case, you can type it in. There's a little chat bar, top left, blue square. If you type in a question there, we can pass it on. But I don't know if check really quick, and then we'll go on. Come back to you in a second. No, no, we're good. Okay. We'll come back in just a second, okay, Miss Gibson? So we'll go back to Mrs. Adams' class. If you guys have a second question, go right ahead.
We had someone that wondered, do you think there's life on other planets?
I absolutely think there's life on other planets, though maybe not in our solar system. We definitely should keep looking for evidence of life on the planets in our solar system. Mars is one place we've been looking for it, but Mars today is a pretty lousy place for life. There are better places in the solar system for life today, like the oceans that are inside Europa and Enceladus, because those are places where there's active geology, making lots of energy and lots of chemistry inside liquid water. And those are all the kinds of things you'd want to have for life. But one of the coolest things that's happened in the last 20 years is that astronomers have discovered exoplanets, planets orbiting other stars. And I want all of you guys to look out next time you're able to look at the night sky and see all the stars that you can see. Astronomers now think that there is roughly one planet for every star in our galaxy. Think about that for a second. Not every star has a planet, but many stars have multiple planets. And that just seems inconceivable to me that with so many possible places for life, that there isn't life somewhere else. So I think it's out there. It might be really hard to find, but I think it's out there, and we definitely should keep looking.
Excellent. Okay, I'm going to pass on Ms. Gibson's class's question in just a second. Just a note for the people watching on YouTube, don't be shy. Like, you can't ask questions. We have lots of time, lots of questions to ask. So Mrs. Gibson's class asked, you had pictures of Titan. So was that water? What's going on there?
This is one of my favorite questions because it looks exactly like water rivers, except Titan is really, really far from the sun. So you know it can't be water. In fact, on Titan, ice, water ice, regular ice like you might have in a glass, behaves just like rock does on Earth. It's just about as unlikely for water on Titan to melt as it is for rock to melt on Earth. It does happen at special places like volcanoes, but nowhere else. And so on Titan, there has to be a different liquid. And it turns out that Titan's temperature and pressure at the surface are at the triple point for methane. What does triple point mean? Well, it means that you can have solid methane, methane ice, and you can have methane gas. That's what makes up part of the atmosphere. And you can have liquid methane, all existing in the same place. And so there is a methane cycle on Titan, just like there is a water cycle on Earth. You have methane lakes that they evaporate and they make white puffy methane clouds, and the clouds move around with the atmosphere, and then the clouds can rain drops of methane that rain down on the surface, fall on mountains, run into rivers and back into the lakes, and you have this whole cycle. When Cassini was there, the spacecraft, it witnessed this cycle happening. We saw liquid methane lakes. We saw methane clouds form, and we even saw evidence of a methane storm where there were clouds, and then after the clouds were away, it looked like the surface was wet, and then it wasn't wet anymore. And so we know we've witnessed the whole cycle happening, and Titan has this weird methane cycle just like Earth has a water cycle. Now I'm going to anticipate another question. When people learn about Titan's methane cycle, then they say, well, could there be life that uses methane the way that Earth life uses water? And the answer is maybe. Methane's a very different chemical from water. Water has this property called, it's polar. None of you has probably learned about polar molecules in science yet, but it's a very important reason why water is so good at making chemistry happen. And methane is not like that. So the chemistry would have to be really, really different. but can't say it's impossible. And I think it would be really cool to do research on that.
Excellent. All right. Let's go back to Mrs. Astor's class for a second. You're good.
What college did you go to become a scientist?
What college should I go to? I went to Amherst College, which is a very small college in Massachusetts. And it's a certain kind of college called a liberal arts college. And what that means is that you don't study just one thing if you go there. You study everything. So I took science classes, but I also took English and history and anthropology and practice of art. And let's see, I took a class on Chaucer and one on hormones and behavior. And when I took all different kinds of classes, and I learned how to write and express myself, both in writing and in speaking. I did singing, I did all kinds of stuff. And I think that that's really important actually for a scientist. It's important for anybody these days to be able to express yourself well. But if you're a scientist and you want to be able to, say, get money from NASA to do your research, you have to write a grant proposal. And if you can't be convincing in your writing that you're the right person to give NASA money to do this cool thing in space, then you're not going to be able to be a good scientist. So never stop reading, never stop writing. And even when you go to college, you need to study all the things in order to be a good professional.
Excellent. And the gesticulating helps as well. It looks like you're very
that comes from being a teacher.
Yeah. Okay. We've got a question online now from 4th grade class in Hilltop Country Day School in Sparta, New Jersey. Do you think the colorful patterns and colors we see of Earth photographs are accurate? We think that makes our planet special.
Oh, so yes. I think one of the cool things about space is the way that it is given us a perspective on our home planet. And whenever we turn back and look at our own planet, you got to say our planet, I mean, we're biased, of course, it's where we live, but it is a uniquely beautiful planet. It's a jewel floating in space. It's a marble. It's got these beautiful deep blues and the swirling white clouds over the deep blue of the water and all the different colors on the land, not just the green of the plants, but the yellows and reds of geology. And it changes all the time because of those shifting patterns of clouds. Sometimes it hides everything underneath it. And if you read books by astronauts, they'll talk about just how mesmerizing and amazing the view of Earth is. In fact, I feel like I want to grab a book if I can find it. I will in just a second. It's called The View from Above by Terry Virts. It's one of the books I recommended this year. Terry Virts is an astronaut, and he took lots of photographs out the cupola of the space station. And he talks about how during the daytime, when you look at Earth, you can hardly see any trace of human habitation. All you see are the beautiful swirling patterns on the surface of Earth. And then at night, you can't see any features on Earth except the lights of cities. And so all of a sudden it shines as all of human technology is shining into space. And so the astronauts just write about how amazing it is to look at our beautiful home planet.
Excellent. We actually did a Google Hangout with Terry Virts earlier today. So if people want to watch that, they can. So small world. So Miss Gibson, Miss Gibson, I'm going to try and see if your mic works. But if not, I'll pass along the question. It works. Is it working? Maybe? No? I mean, I know you can hear me. We can't hear you. That's the problem. But I'll pass on the question. Okay, so the question for Mrs. Gibson's class is, where is it? How do all the planets work together, Emily?
How do all the planets work together? Well, they all orbit the sun, and some of them influence each other's motions. But I have to say that the real influencer, or some people would call him the bully in this case, is Jupiter. So the sun is at the center of our solar system, and all the planets orbit that. But Jupiter has almost all of the rest of the mass in the solar system, and it's mass that makes gravity. And Jupiter exerts a lot of influence on everybody else. So if you're ever going to write a story about the planets and their personalities, Jupiter is the big bully who makes everybody do what he wants them to do.
Excellent. All right, we got a second question online. Same school from New Jersey. Now, we talked about life a little earlier, but what about intelligent life, aliens? Do you think there are aliens out there somewhere? The inevitable question.
I think, again, there are so many planets and so many galaxies. I think it's likely. I also think it's unlikely that we'll ever talk to any because the distances are just so incredibly large and time is incredibly long. I'm a professional space person, and even I can't really understand how deep time goes. We throw out these numbers like our Earth is 4.6 billion years old and our galaxy is 13.5 billion years old. But I still really don't properly understand how much time there is out there. And if you think about the fact that humans have only had technology for 500,000 years, that's just a teeny weeny tiny fraction of the age of the solar system and even the age of the universe. And so if there was intelligent life nearby us, the odds that they existed at the same time that we do is really pretty low. So it may be kind of lonely out here, which is maybe a good reason why we should all treat each other well.
Outstanding. All right, so I'm going to go back to the classes one last time. Ms. Gibson, please do write in another question if your class has one. But first, we'll go to Miss Adams' class.
We had a question wondering if you would ever like to go to space.
I get that question a lot. And my answer has been changing over the years. So first of all, my answer is always no. I'd rather not go to space because I'm very comfortable here in my messy home office. I can get up and get a snack anytime. I don't have anybody telling me what to do. And I'm always really very happy with all of the beautiful pictures being sent back by space robots. But the way that my answer is changing is that the more sophisticated our space robots get, the more sending them out into space is like us going to space. And so I really feel like the future of human exploration and the future of robotic exploration are coming together, where someday we all could be exploring Mars by living virtually through the experience of a robot that's exploring Mars. I mean, you play VR games, right? So just imagine you could have a robot that you control with the motions of your arms and your legs, and you see through its eyes and you hear through its ears, and you could be exploring Mars or even someplace much nastier like Titan, where you die in an instant by being cold, or Venus, where you die in an instant by burning up. And all of those places, we're never going to send humans directly into those places, or not for a long time. But we can send robots, and you could be in there in a comfortable space station office, exploring the surface through those robots. So that's one way I would not mind going to space. If I could be comfortable, if I didn't have to deal with extreme cold and extreme heat. I live in Los Angeles. My kids think it's cold when it's below 50 degrees. So I like being comfortable, but these robots, they're amazing, and they go to all these places that I can't go.
Excellent. All right, let's go to Mrs. Aspen's class. You guys have another question.
What is your favorite planet?
It's like asking me to name my favorite kid. So I think that I have to say that Earth is my favorite planet for all the reasons that I said before. It's so beautiful. It's the one that has life. It has such diverse geology. And as for the rest, there's something I love about every one of them, but there's also all the moons to love. I mean, there's all these wonderful places. There's our own moon. There's Jupiter's moons, Io, Europa, Ganymede, and Callisto. There's Ariel, Umbriel, Titania, Oberon, and Miranda, and there's Triton, and I almost forgot the ones of Saturn. There's Mimas, Enceladus, Tethys, Dione, Rhea, Hyperion, and Iapetus, and Phoebe. There's all these different places. Oh wait, there's all the trans-Neptunian objects. There's Pluto and Eris and Haumea and Varuna and Ixion and Quaoar and Sedna. There's all these different places to explore. I can't possibly pick a favorite one.
That was the best. You must have practiced that. That was a beautiful list. All right. Question from one of our classes is from, again, Hilltop County in New Jersey. If you could choose another field of science to study, what would it be?
So I often feel like I went into geology and then planetary science because I didn't have to specialize too much. I got to study like a little bit of everything. And so I feel like if I chose another field, it would maybe not be science. It would be something where I could do something completely different. I like architecture. I like clothing design. I like, I don't know, I like all kinds of stuff. So it's really hard for me to pick another field, but ultimately, as you can probably tell, I really like explaining things to people. So probably no matter what field I do, I would wind up not being an active researcher or whatever. I would wind up being the person who explains things. So I will say that even though I now work for the Planetary Society and I'm a science writer by trade, the place that I always imagined myself working when I grew up was going to be in a science museum. I figured that I would be really good at developing exhibits and writing the little text labels and figuring out what people needed to know in order to be good science citizens and running education programs and things like that. So that's another kind of career I imagine for myself.
Excellent. You're ripping through these. So do you have time for a few more questions?
Absolutely. When I was a teacher in 5th grade, the teachers I think will probably like this story. It was my first year of teaching. And I said, I don't know how people plan 5 days a week. I just can't. I can't possibly do that. I'll plan 4 days a week. And then on Fridays, I'll have the question box where my kids got to ask any science question they wanted. And I would stand up in front and answer. And I have to say, those were our favorite our favorite days in class. And so this is something I love to do. I love kids' questions and I love answering them.
Excellent. I also want to know, earlier when you told the class to thank the teachers, they all clapped. It was outstanding. And so we always thank all the teachers too. What a great job you guys do. A question from Ms. Gibson's class. Do you believe in the multiverse?
Do I believe in the multiverse? I have to say, as a geologist, I like rocks and things that I can imagine experiencing physically. Cosmology and the beginning of time and subatomic particles, all of those topics that I think they're really interesting, but they just I don't know what to do with them. So I don't have any very well-informed thoughts on that one. Every time I try to imagine something like the multiverse, I feel my brain fragmenting, and I wonder if there's like 1,000 of me all coming off this moment in time, and I get confused, and I want to go just hit a rock with a hammer and feel like I'm rooted in the real world again.
Excellent. All right. Last question from the New Jersey class before we do one last one with the last two here. Were you the only girl in your classes?
I was never the only girl in my classes. So there are lots of women entering science. As I pointed out, my professor at Amherst was a woman, but she was the only woman professor in her department. So it was very clear to me that there were a lot of young people, a lot of young women entering science. And, you could ask a similar question about non-white people too. There's not very many professionals that you can see. There are some, and I respect them a lot, but there's not very many. But there are more entering at the younger levels. And so what science has to really work on is making sure that these people, when they're young, are able to stay in the field. And progress is being made, but it is too slow. So my advice for women out there, as a student, as a kid, as a college student, and even as a graduate student, I never felt like being a girl limited my horizons. I always felt very well supported by my professors and my peers. But it is really important. I think that the reason that I succeeded in that way is because I had a great network of peers and professors. So when you go to college, and especially when you go to graduate school, mentors are super important. It's important to find somebody who can help you, show you the ropes, tell you what things you need to do at the right times. And it's important to have a network of friends who can support you. And so I think as a kid, as a science-obsessed kid, I was often by myself. I liked being by myself. I liked reading by myself. I liked building things by myself. But over time, I've come to realize how important friendships and relationships with other people are to keep me healthy and to keep me surviving in my career. And I've always been very lucky. And I'm out there to support the people who've been less lucky than I am. I'm trying to give back to the community that built me. And so I'm looking to mentor people who need help.
Marvelous answer, and I'm really, really happy we got that question. All right, let's do our final two. So Mrs. Askren's class with the lineup of question askers. We could go all day, but go right ahead, yeah.
Why is Venus so hot and why is Titan so cold?
Why is Venus so hot? There's a couple of reasons. So one of the reasons is that it is closer to the sun than Earth is. And so it just gets more intense heat from the sun, just like you getting closer to the heat lamp. But there's also another reason, and that's because Venus has a really, really thick atmosphere, and it's made of something called carbon dioxide. Carbon dioxide acts like a blanket. So when heat from the sun, when light from the sun gets inside the atmosphere and it heats up the planet, and the heat gets radiated back to space, it gets stopped by the blanket of Venus's atmosphere, and all that heat stays inside. So it just heats and heats and heats and heats and heats. And that's why Venus is the hottest planet, not Mercury, because Mercury doesn't have this blanket of an atmosphere on it. Titan is cold because it's far from the sun. And it's also cold in part because of the evaporation, all the evaporation of that methane. And evaporation can make surfaces cooler, just like when you sweat, you get cooler. And so that's another reason.
Marvelous. All right, we'll do a final question. So Miss Adams' class, come on up, guys.
Our fourth graders are starting their planet research in December, so they wanted to know if you had a website or book recommendation.
Oh boy, do I have book recommendations. Rather than listing books here, I would suggest that you go to planetary.org/books. And you will find there a post that I posted today with reviews of space books for kids. And if you don't find what you're looking for there, then there are links to past space books for kids. Please send those lists to your school librarians. I have lots and lots of recommendations. I read them all first. And you know what, guys? A lot of the books that you can buy in bookstores have bad facts in them. They're not very well reviewed, but the ones that I'm recommending are mostly correct. It's hard to get all the facts right because there's a lot that's changing right now. But you can find lots of good books out there.
Excellent. And I'll send that link to all the classes when we're done as well. So that'll hopefully make it a little easier for the classes as well. All right. At the end of every hangout, what we do is I'm going to demute everyone's microphone. So Miss Adams' class, Miss Gibson's class, Miss Askren's class. If you guys can join me in saying a huge thank you to Emily. So thank you so much, Emily.
Yeah.
Guys, those are awesome questions. I'll send that link in a minute. Emily, that was outstanding. Thank you so, so much.
You're very welcome. It's always a pleasure to talk to kids. You give me so much energy, guys. Go out and explore and discover things.
Yes, and take control of robots and explore Titan. Yeah. That just sounds wicked. All right. Have a lovely rest of your day, everyone. And if you're joining us for other parts of Space Week, we look forward to having you back. For now, have a lovely rest of your day.